Unveiling how Tesla reinvented the supercomputer. Ever dream of your car driving itself while you play video games on a supercomputer in the trunk? Well, buckle up, because Tesla just upped the game with a brain for their cars that's faster than anything on the road or in your living room. What's shaking internet, fam? Virtual reality James here, your one-stop shop for all things tech that'll blow your mind. We're talking robots that walk your dog, self-lacing shoes, and now, supercomputers so powerful they could probably write a Shakespearean sonnet about your last grocery list. The race for AI domination is heating up, and tech giants are throwing serious computing muscle around. But Tesla just dropped a bomb with their very own supercomputer project. And let me tell you, it's not your grandpa's clunky mainframe. Imagine this. You're stuck in rush hour traffic, but instead of fuming behind the wheel, you're kicking back in your Tesla, blasting some tunes, and crushing a level on your favorite VR game. Sounds like a scene straight out of science fiction, right? Well, hold on to your ray guns, because Tesla is making major strides towards turning that dream into reality. The rise of AI and the need for supercomputers. The key ingredient in this futuristic scenario is artificial intelligence, AI. Systems, like the ones powering self-driving cars, require a monumental amount of data processing. Think about it. A car navigating the real world needs to understand things like traffic signs, pedestrians, cyclists, weaving through traffic, and even the ever-changing moods of jaywalking pigeons. Seriously? Pigeons are chaotic. To make sense of this sensory overload, AI needs some serious computing muscle. Enter the supercomputer. These behemoths are essentially networks of thousands, sometimes millions, of smaller computers working together like a well-oiled machine. Think F1 pit crew, not your grandpa's clunky desktop. This parallel processing allows them to tackle massive datasets at lightning speed. Measured in petaflops, a quadrillion floating point operations per second, supercomputers can churn through complex calculations in a fraction of the time it would take a traditional computer. Companies like Nvidia, with their powerful graphics processing units, GPUs, have become major players in this supercomputer game. GPUs, originally designed for rendering graphics in video games, turned out to be surprisingly adept at handling the parallel processing needs of AI. In fact, NVIDIA's A100 GPU, released in 2020, quickly became the benchmark device for AI training due to its sheer processing power. Tesla enters the ring, Project Dojo. But Tesla isn't one to just follow the crowd, seeing the ever-increasing need for AI horsepower and the ballooning cost of using pre-built solutions like NVIDIA GPUs. Tesla reportedly spent nearly $100 million on S alone for their full self-driving beta. They decided to throw their hat into the ring with Project Dojo. Here's where things get interesting. Unlike most companies that rely on existing chip technology, Tesla took the build-it-yourself approach. This philosophy, known as vertical integration, is a hallmark of Tesla. They like controlling as much of their production process as possible, from designing their own battery cells to writing their own software. Tesla also embraces first principles thinking. This means ditching traditional methods and approaching problems from scratch. So, instead of just tweaking existing supercomputer designs optimized for a wide range of tasks, they designed Dojo entirely for their specific needs, training their self-driving AI, a task that involves processing a very specific type of data, real-world video captured by car cameras. Dojo Deep Dive. Dojo is a bespoke hardware platform, meaning it's custom-built for Tesla's AI. One of the biggest challenges for self-driving cars is processing the enormous amount of visual data captured by their cameras. A single Tesla car can generate terabytes of video data per day, and Dojo is designed to tackle this head-on. Think of Dojo as a super-efficient computer chip specifically designed for video processing. It's a system on a chip, SoC, cramming all the essential components, processor, memory, and I/O, input-output, onto a single piece of silicon. This eliminates the need for wires and connectors, minimizing bottlenecks and boosting processing speed. Traditionally, SoCs are limited in their processing power, but Tesla's custom design allows Dojo to pack a serious punch. But Dojo doesn't work alone. Multiple Dojo chips are combined into modular units called tiles. These tiles act as a single unit, further amplifying the processing power. Each Dojo tile integrates 25 Dojo chips, along with the necessary hardware for power delivery, cooling, and data transfer, essentially creating a self-sufficient mini-computer. The story doesn't end there. Tesla, ever the innovator, recently unveiled Dojo 2. This iteration utilizes a cutting-edge technology called wafer-scale processing. Imagine taking the entire Dojo tile and shrinking it down to fit on a single silicon wafer, the foundation upon which most computer chips are built. Traditionally, chip manufacturers like TSMC, Tesla's chip manufacturing partner, create multiple chips on a single wafer and then cut them out like cookies. This leaves some room for error, as not all chips on a wafer are perfect. Wafer-scale processing eliminates this issue by essentially creating one giant chip on the entire wafer. This allows for even faster communication and lower latency. Think of it as the information highway getting wider and smoother, because data doesn't have to travel between separate chips. The benefits are significant. Dojo 2 promises to be even more powerful and efficient than its predecessor. It's worth noting that Tesla isn't the only company exploring wafer-scale processing. Cerebras Systems, another tech player, has entered the ring with their own super powerful AI chips built using this approach. Their third-generation chip, boasting over 46,000 square millimeters of surface area and containing a staggering 4 trillion transistors, currently holds the title of the fastest processor on Earth. However, Dojo 2 utilizes a custom architecture optimized for Tesla's specific needs, making a direct comparison difficult. This iteration utilizes a cutting-edge technology called wafer-scale processing. Imagine taking the entire Dojo tile and shrinking it down to fit on a single silicon wafer, the foundation upon which most computer chips are built. Traditionally, chip manufacturers like TSMC, Tesla's chip manufacturing partner, create multiple chips on a single wafer and then cut them out like cookies. This leaves some room for error, as not all chips on a wafer are perfect. Wafer-scale processing eliminates this issue by essentially creating one giant chip on the entire wafer. This allows for even faster communication and lower latency. Think of it as the information highway getting wider and smoother, because data doesn't have to travel between separate chips. The benefits are significant. The future of Dojo, a risky bet? While Dojo's potential is mind-blowing, scaling it up into a full-fledged supercomputer is no easy feat. Deploying and managing such a complex system with thousands of Dojo tiles working in concert presents a significant engineering challenge. Heat generation and power consumption are also major concerns. Additionally, Tesla still relies heavily on NVIDIA GPUs for a significant portion of their AI training needs, particularly for workloads outside of self-driving car development. Ultimately, Dojo is a long-term bet, a high-risk, high-reward gamble. If successful, it could revolutionize not just self-driving cars, but AI development as a whole. Dojo's custom architecture and wafer-scale processing technology have the potential to push the boundaries of AI computing power and efficiency. However, the challenges of deployment and competition from established players like NVIDIA remain significant hurdles. Only time will tell if Tesla's gamble pays off. But one thing's for sure, the race for AI dominance is heating up, and Project Dojo is definitely a game changer. So, will Dojo become the ultimate AI training machine, or end up as a high-tech paperweight gathering dust in Elon Musk's basement? Only time will tell. But one thing's for sure, the future of AI is getting more exciting and confusing by the day. If you want to stay ahead of the curve and avoid getting left behind in the robot revolution, be sure to smash that subscribe button and join the virtual reality James fam. We'll be diving deep into all things tech, from self-driving cars that hopefully won't crash to robots that hopefully won't take over the world. See you in the next video.